Hi, my name is Felipe Moriel. I'm an assistant professor at the Department of Animal Science from NC State University. But my office is actually located at the Mountain Research Station located in Waynesville, North Carolina. So in this presentation, I would like to talk about the forage quality and also animal nutrient requirements and how those factors affect the annual forage demand in your operation. So first, is forage quality the same as forage nutritive value? There are a lot of people that use those terms interchangeably, but they actually mean a different thing. So forage nutritive value is the actual chemical composition of that forage. It's how much protein, how much energy, how much fiber and minerals you have in that forage, and also the how digestible is that forage. Whereas forage quality includes not only the nutritive value of that forage, but also how much the animal is consuming. And then we usually express forage quality as animal performance, such as average daily gain, body weight gain, and milk production. So, animal performance, or in other words, forage quality, as I said, is determined by how much the animal is consuming and also the composition of the forage that the animal is consuming. So to illustrate that, this is a table where the columns they represent the percentage of energy in a dry matter basis, whereas the rows they represent the dry matter intake in terms of percentage of body weight of that group, and then the numbers in the middle that represent the average daily gain of that group of heifers. So if we provide the same amount of forage for several groups of heifers, but for each group you provide a hay that has a greater energy concentration. As you increase the energy concentration, as long as the intake remains the same, the animal will consume more nutrients, so he will perform better. So there's a linear increase in the average daily gain of those heifers. Same thing happens if you provide the same forage, but at increasing levels. So as long as the animal is able to consume whatever you're providing, as you increase the amount of forage being consumed, consume more nutrients, and then the animal will perform better. So as you probably imagine, there are several factors that will influence the forage intake, and then several factors that will influence the nutritive value. So let's talk about each one of them. So those are all the factors that will influence the forage intake of animals. We don't have time to go through all of them, so we will just focus on three major ones. And the first one is the animal nutrient requirements. How much the animal is going to consume will depend on how much the animal demands per day. And as you guys probably know, is there are several factors that will influence the nutrient requirements of those animals. First is body weight, the rate of body weight gain, breed, sex, age, temperature, physiological state, the previous nutrition of those animals, and also the level of activity. So the first one, body weight. Animals that are heavier, they demand more nutrients. So in this case here, we have count size. We have three counts: a count that is 1,000 pounds, a count that is 1,200 pounds, and a count that is 1,400 pounds. But all of them are producing the same amount of milk, 10 pounds of milk per day. So as you increase the size of those counts, you increase the amount of nutrient demand. You need more pounds of TDN, of total digestible nutrients, and more pounds of crude protein to meet their requirements. A cow that is 1,000 pounds, she demands about 12.4 pounds of TDN, where a cow that is 1,200 pounds, she demands about 13.8 pounds of TDN. That is just a 1.4 pound increase in energy requirements if you replace a cow that is 1,000 pounds from a cow that is 1,200 pounds. That doesn't seem to be much, but when you consider the energy concentration of tall fescue, for example, which is 60% of dry matter, if you divide that 1.4 pounds of TDN by 60% TDN in the tall fescue, that means that you need to increase her forage offer by 2.3 pounds of pasture dry matter per day. And also, that doesn't seem to be much in one day, but when you consider the throughout the year, that represents about 850 pounds of dry matter increment per year per cow. If you replace that cow that is 1,000 pounds for a cow that is 1,200 pounds, and if you also consider the size of your herd, that's going to have a substantial effect on your forage demand in a year. And also, if you consider that the animals do not have 100% grazing efficiency, and let's say that they consume only 50% of what you provide, that means that you have to provide twice the amount of what they need so that they will consume 50% of that and still meet their requirements. So, in other words, in this scenario, that means you're gonna have to increase your forage offer by 1,700 pounds from your original forage offer, so that this cow that is 1,200 pounds will consume 50% of that offer and still meet her nutrient requirements. So that count size will have substantial impact on your annual forage demand. The other factor that will influence the forage demand in your operation is the milk production of those cows, and in fact that has a greater impact than count size. Let's say here that you have 3 cows, right? Each one of them has 1,000 pounds of body weight, but one is producing 10 pounds of milk, the other 20, and the third cow is producing 30 pounds of milk. As you increase the milk production of those cows, you're gonna demand more nutrients. You need more pounds of TDN, you need more pounds of crude protein to meet her requirements. So a cow that is producing 10 pounds of milk per day, she demands 12.4 pounds of TDN. If she produces 20 pounds of milk per day, now she demands 14.8. You're increasing her requirements by 2.4 pounds of TDN per day if you replace that cow that was producing 10 pounds of milk per day with a cow that now produces 20 pounds of milk per day, but it still has 1,000 pounds. So let's do the calculations as we did before. And if we assume the TDN concentration of tau fascio again of 60%, if you divide 2.4 pounds of TDN by 60% of TDN, that equals to 4 pounds of pasture dry matter that you have to increase from your original offer just to make sure that those cows will meet their requirements to produce 20 pounds of milk compared to producing 10 pounds of milk. And again, one day doesn't seem to be much, but if you account for the entire year, that represents 1,500 pounds of pasture dry matter per year extra that you will have to provide to make sure that those cows will meet their requirements. And again, the cows, they do not graze with 100% efficiency. And let's assume that again she grazes just 50% of what you provided. That means you're gonna have to increase your forage offer per cow by 3,000 pounds in a year to make sure that she will consume 50% of that and still meet her nutrient requirements that now increased because she's producing more milk. And you not only have to look at count size and milk level itself, but you also have to look at them together. In your herd, you have cows that are 1,000 pounds, others are 1,200 pounds, others are 1,400 pounds. And you also have cows producing 10, 20, or 30 pounds of milk per day. So just because she's lighter, that does not necessarily mean that she will have lower nutrient requirements. In this case here, a cow that is 1,000 pounds and she's producing 30 pounds of milk per day, and it's highlighted here in red, she has the same nutrient requirement of a cow compared to a cow that is 1,400 pounds but produces less milk, produces only 20 pounds of milk per day. So you have to look at both of those factors to determine how much forage you're gonna need in your operation. Now, besides milk production and cow size, body condition score of those cows also affect how much energy those animals need. In this table here, the columns represent cows with different weights, 1,100 pound to a 1,400 pound cow, And then the rows, they represent the body conditioning score from 2 to a 9. And then the values in the table, in the middle of that table, represent how much energy you need to provide in megacalories to increase the body conditioning score by 1 point. For instance, if we move that count from a body conditioning score of 4 to 5, and she's 1100 pounds, you need 207 megacalories to increase the body conditioning score from a 4 to a 5. But if you increase her body conditioning score from a 5 to a 6, now you demand 242 pounds megacalories just to increase the body conditioning score. So as you realized, the amount of energy needed to move a count from body conditioning score of 4 to a 5 is less than the amount of energy needed to move a count from a 5 to a 6. And that's because body conditioning score is an indication of the degree of fatness of those counts. The greater the body conditioning score, the greater the percentage of fat in the body. And to deposit 1 pound of fat demands more nutrients than depositing 1 pound of muscle. When you move her from a 4 to a 5, she needs to gain about 75 pounds of weight. She also needs to gain 75 pounds when you move her from a 5 to a 6. But because of the composition of the gain is different, because that count has a greater fat percentage in the body, you need more energy to increase her body condition score from a 5 to a 6 compared to increasing from a 4 to a 5. So that also will have an impact on how much forage you're going to need. In the case that we were talking about, it's a 35 megacalorie difference when you move her from a 5 to a 6 compared to a 4 to a 5. And also that doesn't seem to be much, but considering the size of your herd and how much energy you have in the pasture, that will eventually become a substantial amount of forage needed in a year. And not only that, but you also the nutrient requirements of those animals will depend on the physiological state of those animals. In this figure here, we have a cow that is 1200 pounds, and she's producing about 20 pounds of milk per day. And let's say that she calves on month 0, and then 7 months after she calves, you wean that calf. So she stops lactating, she stops producing the milk, so her nutrient requirements decreases. That's the time where she reaches her lowest point of her nutrient requirements curve. And compared to this period in this figure, around 7 months since calving, lactation may increase her nutrient requirements by up to 33%. And also late gestation, right? The calf that's inside that cow, 75% of that calf growth happens during late gestation. And because of 75% of that calf is growing during late gestation, you also increase the nutrient requirements to meet the nutrient requirements for gestation. So that itself increases her energy requirements by 24%. So the nutrient requirements of that cow is not constant. It will depend on those factors that we mentioned before, and it will change throughout the year. So the goal is to match the chemical composition of the forage available in your environment with the nutrient requirements of your herd. So let's do one exercise here, and this is the protein requirements of a mature cow during late gestation. She's about 1300 pounds, and then in November she needs 7% crude protein. In December she's gonna need about 8, and January she needs 9, and then she's gonna calve at the end of January. And then you have two pastures. You have to pick one. Pasture A has 9% crude protein in November, 8 in December, and 7 in January. And pasture B has over 10% of crude protein during the entire this entire period. So which one then will you choose to meet the requirements of those cows? you guys are probably gonna choose pasture B, which has a greater protein requirements, has a greater protein concentration than the requirements shown in the first table. But you cannot answer that question because I didn't tell you how much pasture you have. How many of you actually ever seen overgrazed pastures? So it doesn't matter the chemical composition of that forage if you don't have enough to provide to those cows. You can always sample a pasture that is overgrazed and you send to the lab for analysis. And then when the results come back, it might show forages with greater than 10%. But that doesn't mean that the animals are consuming enough of that forage. A piece of steak and the whole steak, they had the same crude protein concentration. But which one of them will meet your protein requirements? The slice of that steak or the entire steak? So don't worry about the chemical composition of your grass before worrying about how much grass you're actually providing to those animals. The percentages, they don't mean anything if you don't know how much is available to your animals in this day, in any given day. So besides animal nutrient requirements, you also have the chemical composition affecting how much those animals will consume. In this case here, as we increase the crude protein concentration in the forage, there's an increase in the forage intake by those animals. And that happens because as you increase the crude protein concentration from 4 to 8, for example, you're increasing the amount of nitrogen in the rumen. The microorganisms in the rumen, they are just like any other animals. They also have nutrient requirements. And when the forage crude protein concentration is below than 8, you cause a nitrogen deficiency in the rumen. So those microorganisms, they are deficient in nitrogen. Because of that deficiency, they are not able to perform as well as they could. So they do not digest the forage as much as they could. And that causes more forage to remain in the rumen, and you're gonna decrease the forage intake. But as you increase the crude protein concentration of that forage, you're fixing that nitrogen deficiency, and then the microorganisms are able to perform better. They will digest more forage, and that means that you're going to increase the intake of those animals, but up to a point where whenever those microorganisms they reach their maximum capacity to digest forage, it doesn't matter if you provide forage with a greater crude protein concentration. The microorganisms are already digested as much as they can, so the animal is consuming as much forage as it can. So increasing the crude protein concentration beyond that point will not increase the intake of those animals. Besides crude protein, you also have the digestibility of the fiber. Also, if you increase the amount of fiber, or as you increase the digestibility of that fiber, more forage is digested, you increase the dry matter intake, consume more nutrients, and then you have a greater performance. In this case here, you have a greater milk production when you increase the fiber digestibility from 45 to 55% of the dry matter. And besides forage chemical composition, the third main factor that will determine the forage intake of those animals is herbage mass. How much of that forage you are providing. As you increase the amount of forage available, there's more forage for the animals to consume. He's going to consume more, and it will increase her nutrient intake, and they're going to perform better. But up to a point, until the point where they reach their maximum intake. Beyond that point, it doesn't matter if you increase the herbage mass. The animals are already consuming their maximum capacity. So beyond that point, you're just wasting forage because the animals are not able to consume the extra amount of forage that you're providing. So the three main factors that will influence forage intake are the animal nutrient requirements, the chemical composition of that forage you're providing, and also the herbage mass, how much forage you're providing to those animals. Always make sure that you're going to provide enough mass to those animals before you think about the chemical composition of what you're providing. Now, you also have a lot of factors that will influence how the nutritive value of that forage and how the animal will perform. I've just showed that figure where as you increase the herbage mass, there's an increase in the amount of forage available. There's an increase in the forage intake, and those animals, they will perform better until you reach a point where the animals, they reach their maximum capacity, their maximum intake. So beyond that point, it doesn't matter if you increase the herbage mass, the animals will not perform better. So what happens in this case here, I show for a forage that it's about 60% digestible. But what happens when you provide forages that are less digestible than that? You still have the same response. For example, a forage that is 50% digestible, you're still going to have the same response, that as you increase the herbage mass, then there are more forage available to the animal. They will increase their intake and they increase their performance up to a point where they reach their maximal intake. Beyond that point, increasing the herbage mass does not have any effect. So in this case here, the first limiting factor is the herbage mass, the amount of forage available to the animal. Whenever you reach their maximum intake, what will determine the performance of those animals is the digestibility of that forage. The better the forage, the greater the average steady gain. So the first limiting factor is herbage mass. Then the second limiting factor that will determine your maximum performance is the chemical composition of that forage. So again, there are several factors that will influence the chemical composition of that forage. And the first factor will be genotype. Legumes, they tend to have a greater chemical composition than grasses. They have a greater protein concentration, they have less fiber, there's more digestible, greater energy concentration, and that may result in a better animal performance. You also have warm season grasses and cool season grasses. In this picture here, the researchers, what they did was they got a leaf blade of a warm season grass and a leaf blade of a cool season grass. They put inside the rumen of beef cattle, and 48 hours after placing in the rumen, they remove it from the ruminal environment and they look it under the microscope. So in these figures here, look how much tissue was digested in the cool season grass. Look how much black spaces and empty spaces you have in that leaf blade compared to that warm season grass. Look how much vascular tissue is still remaining in that warm season grass leaf blade 48 hours after it was digested in the rumen. And that's because the differences in the morphology between warm season grass and cool season grasses. Warm season grasses, they tend to deposit more undigestible material in their vascular tissue. That's why it makes it harder for the microorganisms to digest. It takes longer. That's why 48 hours after digestion, you still have a lot of tissue that was not degraded by those ruminant microorganisms. And that explains why usually cool season grasses has a greater chemical composition than forages with compared to warm season grasses. Now, besides genotype, you also have maturity, right? As you increase the maturity of that forage, you decrease the chemical composition, you decrease the intake, decrease digestibility, and you're going to decrease the performance of those animals. And that's because in this figure here, the gray, this is the cell wall of a plant. The gray part is the cell wall, is what we call the fiber, and the white part is actually the cell contents of that plant. The cell contents are much more digestible than the primary wall, than the fiber. So what happens is, in a fresh forage, the thickness of that cell wall, the thickness of that fiber is relatively thin. So you have a greater cell content, right? The proportion of the tissue that is highly digestible is much greater than the proportion of cell wall, which is less digestible. But as the plant matures, the thickness of that cell wall gets bigger. So you're decreasing the proportion of cell contents. and you increase in the proportion of the cell wall. So the end result is you're going to decrease the proportion of tissue that is more digestible, and you increasing the proportion of the tissue that is less digestible. And also, you also have the deposit of lignin between those cell walls, and lignin is 100% undigestible. And then, so what happened is the microorganisms, they start to digest the forage from inside towards the outside. So they first digest the cell contents really fast, and as they move to the cell wall, the digestion decreases a little bit, it takes them longer, and once they digest an entire cell wall, whenever they're trying to move to a different cell wall, they cannot do it because of that wall of lignin that was deposited. That's why, as you increase the maturity of that plant, you're decreasing the digestibility. You decrease the cell contents, increase the cell wall, and in addition to that, you're depositing undigestible material between those cell plants. And another factor that will influence the chemical composition of that and of the forage, and it's also associated with maturity, is the leaf to stem ratio. As the plant matures, there is a greater proportion of stems in a lower proportion of leaves, and stems that are less digestible than leaves. That's why as the plant matures, you not only have those morphological changes in the cell wall that I just showed you, but you also have difference in the composition of that plant. You're affecting the leaf to stem ratio. You're decreasing the amount of leaf, and therefore you're decreasing the nutritive value of the whole canopy. And beside those factors, you also have season. Doesn't matter the species, you will always have seasonal effects on the nutritive value of those forages. For instance, tall fescue, it has a greater chemical composition, okay, a greater nutritive value early fall, decreases during late fall and in the winter, increases again during the early spring, and then decreases during the summer. And that happens with all the species. It doesn't matter, you will always have this effect. So you not only have a seasonal variation in nutritive value, but you also have variation in the nutrient requirements of those animals, as we talked about. So the goal is to match the the periods with the high nutrient requirements of those animals with the periods where your forage has a greater nutritive value. And now the last factor that I'll talk about that will influence the nutritive value of those forage is the actual temperature of the environment. In those two figures here, we have a tall fescue leaf blade that was grown at 65 Fahrenheit or 86 Fahrenheit. It's the same plant, the same species, but grown at two different temperatures. And then they placed those leaf blades in the rumen, and 48 hours after the digestion, they look it under a microscope. And so again, look how much tissue was digested in the tall fescue that was grown in an environment where the temperature was 68 Fahrenheit, compared to a tall fescue leaf blade that was grown in an environment where the temperature was 86 Fahrenheit. The greater temperature increases the deposition of lignin in the vascular tissue. And remember that lignin is undigestible. It makes it harder for the microorganisms to digest it. And that's why forages that are grown in a greater temperatures, they have lower chemical composition compared to forages that are grown in an environment with a lower environmental temperature. So we talked about the factors that will influence forage intake and also some of the factors that will influence the chemical composition of that forage. But how can you predict the forage quality? How can you predict the animal performance? And that's really a challenge in a grazing situation. If you are in a dry lot situation, you can grind the hay. You know what you're providing. You know how much you're providing, how much the animals consumed, what they consumed, and then you know how much they need, and that's really easy to estimate their performance. But in a grazing situation, that's really a challenge. First, how well can you mimic what the animals are consuming? We all know the animals are able to select best parts of that forage that has a greater chemical composition. So it's really hard, if not really complicated, to mimic what the animals are consuming. And you also have a lot of variation in chemical composition within a given pasture. For instance, within the same pasture, you have different soil composition, different soil fertility, and that will change the chemical composition of that forage. So within the same pasture, you have a lot of variation, and you can imagine how much variation you would actually have in your entire farm. So it's really complicated to mimic what the animals are consuming, and also mimic how much to get a representative sample of your operation. And then in this presentation, we're not going to talk much about how to do that. But if you get a representative sample of that forage, you can always send to the lab for analysis, and then you're going to use some prediction equations available online that will estimate how much that animal is able to consume. Again, in a gray situation, you don't know how much pasture the animal is consuming, so what you're really going to do is to estimate based on the chemical composition that you're providing. And again, this is not 100% accurate, but it will at least to give you an idea of what you expect in terms of animal performance. I included additional information on this presentation of how to manage count size and body condition score. You just need to click on the links, and that will lead you to the web page with more information. Or you can also contact me, send me your questions via an email, or you can call me on the phone number shown at the bottom of that slide. And with that, I would like to thank everybody to listen to this presentation. Again, if you have any questions, please contact me via email or phone. Thank you.